This is our second video on light, and we'll focus on refraction, the bending of light as it moves from one medium to another. Light bends as it travels from air into water. This occurs because light travels more slowly in water than in air. So part of the light is still in air and traveling faster, when part of the light is in water, traveling more slowly, which is the source of the bending. How much light slows down is described by a dimensionless parameter known as the index of refraction, n, which can be looked up for a lot of substances. The speed of light in a vacuum is a constant denoted by the variable c. The actual velocity is the speed in a vacuum divided by a substance's index of refraction. So, n of a vacuum is 1. Light doesn't slow down much in air, n equals 1.0003. Water is 1.33, glass about 1.5, diamond 2.4, and there are crystals with even larger n. So the change in n also describes how much the direction of light changes. Light would bend more traveling from air into water than from water into glass. Here we can see light traveling into glass. We draw in the normal to the air-glass interface and measure angles with respect to it. Note that light bends toward the normal when moving into a larger n. Note that when light moves from glass back into air, decreasing n, it bends away from the normal. Note that the two bends are symmetric in that the ray of light ends up traveling on a path parallel to its initial path. Let's look at a demo that loosely motivates what do fish see. We have a coin placed in the bottom of a cup. Note that our camera's perspective does not allow us to see the coin. We pour water into the cup and note that we now can see the coin. Light traveling away from the coin bends away from the normal as it traverses the water-air interface. This illustrates what is referred to as a fish-eye lens. Fish can see quite a bit above the waterline because of light bending toward the normal. Let's check our understanding with a peer instruction question. Classroom students should follow normal procedures or instructor guidelines. Viewers not in a classroom should record your vote and explain your reasoning on a piece of paper. Please pause this video and answer the question. Note that light coming from the fish moves from water into air, and the decrease in index of refraction indicates that the light rays will bend away from the normal. Thus, the fish appears to be further away than it really is. Let's conclude our video by looking at examples of a classic refraction demonstration, making things disappear by matching the index of refraction. There are a number of products that have an index of refraction very close to water. Jelly marbles available on Steve Spangler's website, for example. These appear to be simple glass spheres, but when water is added, they disappear. They are still present, of course, but they are constructed of a specific polymer that can absorb a lot of water. Thus, they started out, about an hour ago, as much smaller beads and were soaked in water. They can absorb a lot of water, many times their weight. So now they are effectively little balls of water, in water. No wonder we can't see them. Light moving through them is not bent since there is no change in the index of refraction. Here I have placed a Pyrex test tube in a beaker of water. Note that the test tube is apparent due to the difference in the indices of refraction. N of air is approximately 1.0, water 1.33, and Pyrex glass 1.47. If I remove the air by filling the test tube with water, its presence isn't quite so obvious, but I still have a bending of light on the inside and outside of the test tube at the water-Pyrex interface. Now I place a Pyrex test tube in a beaker of mineral oil, N equals 1.46, and its presence is quite obvious. However, if I also fill the test tube with mineral oil, it becomes very hard to see. We have very closely matched N of Pyrex of 1.47 with that of mineral oil 1.46. This slight difference in N keeps it from disappearing completely, and the dirt and scratches on the glassware also contribute.